we'll pop over to here to talk about where we've come. So last week, to review the 8-4s that we've done, this was developing pi, which essentially, if we take a regular polygon with a radius of 1, which means from the center out, the more sides we get, the closer we get to determining pi as the ratio. Then 8-4-2, which we did Friday, and pretty much the class just walked themselves through it, was dealing with arcs and sectors, essentially being portions of circles. So if we have 72 degrees, that's 72 out of 360, and I can determine either the arc length or the sector area using that portion.
One of them, you gotta choose wisely.
Choose wisely. And we walked by and we're like, oh wait, that's tonight? Like, how did we not know he was here tonight? So really interesting idea, right? What if the Earth stopped for just 1 second? And how would that impact things? And ironically, this weekend on Reddit, as I was scrolling through there, you may have seen, there was a meme or whatever you want to say of this, or a comic. I think it was on our comics. And so Fido, stay at this exact spot in time and space. And then the next frame was the dog floating up into, and then the next frame was the dog out in space. Wait, and then it ended up on our, they did the math of saying, wait, how far would this dog be away from us? In a certain amount of time. So this drives some interesting questions that there are real reasons to solve these things. But, how far do we actually go when we orbit the sun once? How far do we physically travel? Because, if we're talking about, I'm not going anywhere, well, okay, you're not going anywhere relative to the Earth, but we're all going somewhere right now.
And so is the Earth, and so is the
right. So Neil deGrasse Tyson just said approximately we're 800 miles an hour, right? Pretty darn fast. Let's figure out, actually, how far does the Earth travel in one orbit around the sun? Well, what is an orbit around the sun? How long of time is that?
65 days. 1 year.
That's a year?
360.
Yeah.
So let's go 365. Now, we want to be accurate. We can do 365 and a quarter, but that doesn't really one orbit around the sun. We'll call it. It is, it's and a quarter, and that's why every 4 years we actually fix our position on the rotation.
In a billion years, because
we are a tiny speck off.
In a billion years, though, because of
it will matter. They'll have to do something 1,000 a few years. There will be some celebration day probably where they're we get to fix our rotation. Yeah, but for real. So I want to know, as a class, can we? Well, I know we can. If the radius of the Earth is approximately 93 million miles, how far do we travel in a year? Now, do not think we can use Neil deGrasse approximate 1 hour and multiply from that. That's very, very rounded and approximate. We got to do the actual math. And really what I want you to answer here, how off is he in his accuracy? What's the real miles per hour that we're traveling? So I'm going to give you a couple minutes to work on this.
Well, he's talking about the rotation of the Earth, around its axis.
what?
Yeah.
So it'd be completely different.
Well, so there's 2 different questions we can answer here, right? Rotational speed versus big rotational speed. So he's speaking instant. Yeah. He's talking
so our answer
in a
would be
day.
different.
So I'm talking. Yeah, you're right. You're 100% right. I'm talking extrapolated to the whole year. Right. So big distance, not all the individual distances. You're right. So Thomas brings up a whole nother question. We could then calculate how far do we travel in one rotation about the axis. And if we want to answer this realistically of how far we travel in a year, we would actually have to go circle, 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 circles, right? If we wanted to really answer, right?
That was...
Correct me if I'm wrong, but wouldn't this be what we...
Yeah, and we'd have to do it for the sun,
So
too.
we're talking this, just continuous travel.
Wait, Mr. Hudson.
But then that's a circle too.
Mr. Hudson. So, is there a way to, I can't remember, I never remember which one's pi r squared and which one's 2 pi r.
Which measurement involves a unit squared? Length or area?
Okay, thank you.
There you go. That's how you can get your brain to figure it out. So radius I'm holding chalk, so I guess this is what we're doing now.
10,609 miles per hour.
So circumference, if we're using radius, is the 2r pi.
Cosine? When did I press cosine?
Because it's also pi d, right? Pi times diameter. Diameter is this 2r. So our diameter is going to be 186,000 miles.
That is a big number. How many hours?
Multiply that by.
Or you can just know it's 365 days times 24.
Divided by
It's not
24.
very big. It's surprising. They're like
What do
only
you
like
mean?
8,000 divided by 24.
Okay, so once you have once you have the entire circumference.
9,875.76.
That's not. It's not very many hours in a year. It's kind of strange.
Yeah, there's nothing. Wow.
That many miles per hour.
It's only like.
What did you guys
We're only
do?
going
Wait,
like
what are we trying to figure out?
66,000 miles per hour.
How miles
First,
per hour?
how far we travel in one orbit around the sun.
I got
So in a year.
66,000 and I don't think that's right.
No, it is definitely. That's
Oh,
that's
the
the
weight,
miles per
okay.
hour.
Yeah, it's the miles per hour.
But for the distance around the sun,
If
it's
you
a different.
divide the total.
Oh, I'm
distance
doing
by
B.
365
Yeah, you are
and
doing
then-
B.
Yeah, no, I already got it.
So I believe our A should come out to be approximately 584,336
Yeah.
miles.
That's so helpful. Thank you for telling me.
And then for B, you just divide that by 365 and then 24.
So if we find out that we go 584,336, and it would round down, so we can leave it there, miles per year, then if we divide that by 365, that gives us miles per day.
Mhm. Six 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 1.21746.
I got 66. Oh wait, you guys rounded.
66,661 miles per hour.
66,705.
Which did you do? The whole, all of them together?
I just didn't round I didn't round the orbit around the sun part. I just.
Because I got like 66 miles per hour.
66 miles per hour?
Are now sure.
So I took 584,000 or 336
No,
divided by 360.
584 million.
You took off 1,000.
It's 584 million. 336,000.
How am I so off?
233.
Oh, yeah, I'm 3 zeros off.
Yeah, you took off 1,000.
I understand
Two,
what you're saying.
It's 223. At the end of.
Yeah,
at
that's
the end
six.
of the.
So what you do,
It's just 223.
Yeah.
You're not rounding that.
you just multiply the days by 24, and you still got the top number, and then you just
We do that.
got miles per hour.
So 66,705 approximately.
66,661. 66,661 is what I got.
705.
I didn't round.
049.
I had no rounding. Rounding did not exist in this one.
Then how did
Control the speed at which lobsters die.
So wait, if we wanted,
How did you not round it?
and I said something, I was surprised nobody called me on it, but then I just let it hang there.
Well, what did you say?
I said the radius of the Earth.
Oh, that's right.
So the radius of the Earth's travel, right, is 93 million miles. But if we wanted to do the little, like, piggy tail travel, we would need the actual radius of the Earth,
And big
right?
special map.
And how many times it rotated, which we know.
Well, which we know, which would be 360. So, let's talk about this.
No, let's not. Let's go on to the
You're
next.
gonna not? No?
No.
Well, I mean, we could do it. We just have to.
We know how to do it, but we don't want to.
Okay, we can come back if we want to.
Now you just take
Um,
it and then
My smartboard's broken today. It won't capture, so my apologies that it won't capture. So I recently replaced my windshield wipers and did not realize how annoying they had gotten. And just for the fact of like 20 or 30 some dollars to get new ones, it's so worth it when they're chattering the whole time. Because they, like, if you ever had bad wipers or your parents, they, like, when they wipe, they make horrible, horrible noises, kind of like nails on chalkboard. So your wiper, though, does not cover your entire window, because then it would have to go exactly, it would have to pivot from the end of it, right? And that wouldn't make a lot of sense. So they've designed them, they have a gap at the bottom so they can cover more of your window, and then they overlap and do all that stuff. But if you look at what area is covered by this wiper blade, and it has a wipe angle of 120 degrees, calculate that shaded area. So remember, this is complex area. It will be a multi-step problem. We have a radius of 5, and then an extended section that is a 15-inch long wiper blade.
I think I'm joking. No, I ate trail mix and there's like this thin piece of coconut and I ate it.
Did you know that coconuts are extremely caloric?
I don't know what that is.
They have really high calories. There's like 1,500 calories in one coconut. The water tastes.
Yeah, I'm skinny, so I need those. Not a thick boy.
I think it's 1,325 inches.
Talk with your classmates.
Wait,
pi.
for what?
1,325 pi squares. Thinking about left in the thing. I don't know if that's right though. Oh, I did it wrong.
Yeah, because that seems like a really big number.
What's my favorite divided by 3? Okay. Oh, it's 125. It's 125 pi. Units squared, I believe.
So realize I'm going to ask you for the detailed step-by-step of how we do this. Guys, talk with each other. Don't look at me.
So we do the whole thing, which would be. Hold on, don't. We're still working right now. Yeah, but.
Now, there's also multiple right ways. So we could imagine that this was a whole circle, do the math, and then deal with the partial. Or we can do partial from the get-go. In my mind, acting like it's an entire circle first is the easiest way.
Chris, what did you do? I got
Hey, Chris.
392.
Hey, Chris, is Hunter really wanting you to do that? Because it didn't seem like it.
Wait, you got 393? How did I get?
Okay, 392.
I got 392.6990817.
What did you get in terms of
I don't know. I didn't calculate pi.
I didn't actually calculate that. I just heard Christopher talking. Okay, so you didn't get that.
Perfect. There goes
Well, he
the-
got it just the way he got it was by copying off of someone else.
Then he didn't.
That's how you succeed in college, friends.
Adrian tried copying off of Josh and Kahoot, so Josh would purposely put the wrong answer and sacrifice himself.
I did that to every grade.
What a legend, dude.
I don't know what I learned.
Purposefully.
So,
Yeah, purposely.
what do we do first?
Why are you selling grass?
I'm Chris.
We do the whole circle,
Whole circle. So,
which is 400 pi.
so we can act like, 20, and the area is 400 pi, and we're going to work in terms of pi because that makes life easy. Love it.
And then
Continue.
divided by 3 because
Wait, what?
120 is a third of 3.
He called
Do
it-
that later. Otherwise, you're doing extra work now. We don't do now.
Dang
Get
it.
it now.
Okay, fine. Then we do the area of the little one.
Find the area of the small circle.
You could just do an equation.
The area of the small circle is 25 pi, which
Subtract
means
400 pi by 25 pi, and you get 375 pi.
And then you divide that by 3 and get 125.
Yes.
I just did the equation pi 20. Pi 20.
No one cares about your
Fine. Okay, it would be.
if you get to the same, there's multiple right ways here.
No,
So you're
there's
probably
only one
good.
right way.
There's seven.
But I'm gonna give the equation that would make it like so all you have to do is type in the answers.
Sure, but your equation is probably complicated enough that took you most of your time. I mean, you can give it to us, but this process is pretty clean.
Okay, so I got. Hold on, let me check it pi 20 squared divided by 3 minus pi 5 squared divided by 3.
That's so.
That-
Yeah, that's literally just.
Yeah, that's what
But-
Chris was about to talk about.
But it's an equation.
So we get for our purple
That's
area,
literally just doing it all in one.
Yeah, it is. I know it is.
which comes out decimal form to be
392.699 or 0.7.
699.
and that's what, inches squared?
Yeah, inches.
Questions on how we dealt with that? Are you sure? Because then we're gonna go help bake the rest of the cookies.
Wait, what?
What size cookie should have the least amount of
Did you
waste?
figure out your jacket situation?
It has 0
Your
weight.
coat thing.
Oh yeah, I see.
It has an automatic mixer. Yeah, like, which
What'd you end up what'd you end up
Okay,
getting?
so I used a chef coat and pinned it up, but then I was like, okay, so I like a fool overworked scientist, I left my lab coat in the wash, so I had to borrow this from the nutritional department's Jeff. So I made up an amusing story for it.
So Jacob texted me on Friday while we're sitting in our staff meeting. We're about to start our staff meeting. Right? Mr. Sherg's right next to me, and we're all like around the big table in the library. And I just like look up at Tony. I'm like, Tony, you have a lab coat, right? He's like, yes. And he's kind of nervous, and he was like, why? I was like, Jacob wants to borrow it. He was like, so still, why?
So I killed Hunter, and Jacob was a mad scientist.
Why did he need it?
What is
And I
it?
had a.
Party.
So it was really bad because my character has like greenhouses.
What
like a
party is
botanist or
this?
something.
A murder
And
mystery.
they were
Also,
killed
like-
with nightshade.
Weird stuff. But I wasn't the murderer. It was that one.
I didn't actually know.
All right, now that we're talking about murder, I'm gonna go back on Matt. Okay, so
Everyone's
So-
wasn't me though.
one of these cookies is poison. No, okay. So a cookie maker,
It's the nightshade I stole from Chris.
a cookie maker has an atomic mixer. I don't know what that means. That turns out a sheet of dough in the shape of a square 12 inches wide. His cookie cutter, now a lot of this is animated, like if you've ever walked into Krispy
He
Kreme's.
cuts humans with
Cookie cutter cuts out 3-inch diameter circular cookies to maximize the space, right? So they're right up against each other. The supervisor complains that too much dough is being wasted and orders the baker to find out what size cookies would have the least amount of waste. Okay, square, 12 inches wide.
How many humans can he cut?
All of them.
Well, the smaller
So,
the cookies,
Your task, are you sure?
Yes.
are you sure?
Your
If you have
task.
cookies that are infinitely tiny, then there is.
Quit arguing with words. Argue with math.
I did.
Your task. Be able to definitively, and I'm going to stick you guys against each other, be able to definitively say the maximized size of these cookies so you waste the least amount of dough. And I'm going to give you 5 minutes unless you seem done before that. Go.
Radians, no,
Nope.
diameter.
Go.
Okay.
No. There's no wait, Mr. Hudson.
Devil teacher.
Nope.
Devil teacher.
Quit looking at me.
This is about the rules, not the actual question. Couldn't I say, okay, if I said he has infinitely small cookies that he could fit infinitely everywhere, to the point where he will not have any waste, is that definitive?
That is wrong.
Can you do math with infinity?
No.
It's not possible to do that.
You need to make a mathematical argument, and if you can't do the math, you
Can I
can't
share?
use that as your argument.
Can I share?
But like, I know it would work.
Found it.
With each other, you could.
Oh, yeah, that makes sense.
You could use percentages if you want.
I don't know.
What percent is
Yeah.
used versus what percent is wasted?
Because I've just taken them and I've made it about as big as it could possibly be. How much there is. How much waste there is.
So you mean like even a 12-inch wide cookie
Yeah.
versus 1-inch wide cookies?
Wide cookie and
Wait, no, I did say that.
There would be 9 in each one. 9 times 16.
Why would there be 9 12-inch cookies?
He's doing his own math. Don't assume he's doing the same math as you.
Can I share my
Yeah.
thing?
With each other.
They're all the
Okay.
same.
Here, can I? Yeah,
The
they're
waist
all,
is
no
the
matter
same.
what,
The
they'll
waist
be the same.
regardless.
Yeah.
Even with 1-inch cookies.
Yeah, no matter how small you get, there is no point where
And
like,
how big they get.
can I like come up there and explain it?
That's the question.
Are you
Can you?
Yes.
Can you explain why this happens? With math. Can you explain why that's happening?
Okay,
I
since,
can.
since all the
If you can, I'm gonna recenter the board really fast because it's gonna screw you guys up. Because I'm so used to the board sucking, it doesn't mess with me like it messes with you guys.
And what we found so far. Let's start a petition. New math board.
how long have we had smart boards? We haven't.
This is the oldest one in the building.
How old is it?
Somehow it was the first smart board that was bought, and it was bought from Mr. Dove, and then he won Teacher of the Year. So then they moved his into here for Mr. Tewart, and they put up his Teacher of the Year smart board because he won like national
Teacher of the
teacher,
Year
like national Teacher of the Year. Like there's like
Like
people
in
nominated
all of the
like
United
in
States.
the U.S. Yes,
He was the first place.
he was a Teacher of the Year. They do like I don't know, depending on how many people they have nominated and stuff. It's like you meet the criteria, we'll give you this award. He was a fantastic teacher. Made me a lot better as a teacher.
So like
Here's
since
this tip.
You're a pretty good teacher.
You can switch pen style up here. I always advise going pick up a pen. I always advise going calligraphy and then whatever color you want.
so like
All of them. All the colors.
since all no.
You can write in rainbow.
Okay, so I want to say this first. Like all of wait, what? I thought it made it like nice.
If you grab the square tool. Mine isn't set to make straight lines. So here, I will.
Just give me like one small square and one big square.
Yeah.
Yeah? Okay.
Okay. So like let's say
Hold
that
on. Okay, never mind. I thought you were selling square tool.
let's say that we have okay. All circles have to be the same.
There's no.
That's how they're defined. They
And so do squares.
and so do squares. And knowing this, if we put
Yeah,
a if
each
we
weighs
put
the same amount. Each weighs the same percentage. Sorry.
so knowing this, all circles will have this little outside that will be wasted. So if we did an even bigger one, percentage will pretend it's in the circle.
Stop. I'm gonna make stop. I'm gonna make you a superhero.
Oh no.
Wait, that's even worse
Okay, there we go. So I drew a perfect circle. Now you still have this waste, and it'll be the exact same percentage-wise as this.
Now,
So-
can you mathematically represent what the waste in this situation will always be? If you're
you
arguing,
could prob-
it will always be the same.
You could probably find out. Like, let's say I do that 1, I do that 2. Radius of that is
Well, you know physical numbers in this situation. How big's your square?
12.
5.
12.
So
That's
it's.
a square.
I know, but how big is it actually then? Area. How big?
Oh, 144.
So then,
You could
Minus the number.
what do you
Yeah,
mean the
Tom,
number?
Tom.
Take it over, Thomas.
You waste 21.46% of your space.
Yeah, that. So if he just used square cookies, it'd just be done.
Perfect.
Waste no space at all.
I mean,
Recycle it.
so
Wendy's is smart.
does
Yeah,
this
we-
bring up the question of like, is that why Keebler has some square cookies and why like?
That's why Wendy's is so much better than everything else because they use square burgers. Yeah, you're one of those Whole Foods kids.
You guys ever go to eat Reese's and buy
If
those
your
side
burgers are
burgers?
being punched out by a machine, I may not want them.
No, like
Unless it's White Castle.
I have it broke, so like I can't get the whole.
Satya.
Like,
Get
You
some
call
hamburgers
someone
that you
as
make it
as
whole.
machine.
yeah, you know how much
So,
it costs? I did get $3.
I think most of us could get to this proof, but what we could write out for proof here
All of a sudden-
is our total area, 144, then gets split into individual areas for the circles. Whatever the radius is, right, we divide the 12 that is the total by 2 times that radius, into those diameter sections, which makes as many little squares as we have that fit in there, as long as it fits perfectly, or we end up with partials, quote unquote. And then those little squares have the exact same waist, just shrunk down because they're all similar to each other. Perfect. If we wanted the formalized answer, it would be 144 minus 36 square inches is the amount of dough wasted. So 36 pi taken away from that, because the maximum area space here with this giant circle is 6, right, radius. And if we said they're always the same, that's always going to be the case. 144 minus 36 pi.
So he could just sell like really big
He could. Now, it will be the same amount of dough wasted, but then it comes to the questions of what cookies bake faster or better. Like the giant cookie probably wouldn't bake as well because the middle of it wouldn't bake as quickly as the other
They
one.
could be smart about the situation and just use all the waste.
Or you could hire some Roman scientists who like know how to calculate E.
infinitely many
Or they could just sell cookie dough.
That's what I just
No, like something else you could do is just
All right.
all that waste and make separate cookies with that waste.
We're slowly going to get you guys comfortable with radians, and in prepping for the test at the end of the year, which I'm going to start to kind of jump around a little bit because I think we're a little tight on days, we want to make sure you're comfortable with radians. How many radians are in a whole circle?
360.
That's degrees.
Is it 1?
Is it
Infinite 7,000.
So this is why we're reviewing this. Draw a circle on your paper and label that it has 360 degrees.
How would we label 3? Oh.
You just put a pointer.
Then put equals. Remember, radians is how we can, not how we have to, but how we can measure arc length. 2 pi is our standard circle because it's 2 pi times radius for your circumference. So whatever your radius is, it's 2 pi that. That's why it's 2 pi radians, is you get your unit from whatever your radius is.
Quarter pi radians.
So 45 degrees, well, let's start thinking about this. If I cut a circle apart, half of the, let's say we start here rotating, half of the rotation around would be how many radians?
1
Pi.
What?
And because if the whole rotation is 2 pi when we get back over here,
Yeah, so it'll be 1.
half the rotation's 1 pi.
I said
Pi over 2.
So then 90 degrees would be pi over 2, and 45 degrees would be pi over 4. And this is our unit circle. So then, if we look at pi over 3, write down pi over 3.
would that be
Well, what did we say pi equals in degrees? 180. So this is really 180 over 3, which is how many degrees?
60?
That's how we go from degrees to radians, radians to degrees. It's all 180 equals pi.
So what's
That's
the?
it.
I was watching some Khan Academy to catch up, and he started talking about radii. Is that
Radii.
Radii,
Multiple
probably.
radiuses.
No, it was like R-A-D-I-I.
Radii.
Yeah,
Yeah.
radii.
It's plural for radius.
No, it was R. It had 2.
That's what
Yeah,
it is.
Radius.
Yes.
So don't ask a question if you won't accept the answer.
Oh, so it's like actually, so like.
Yes.
It is the multi. Okay. No, I get. Well, I was making sure that like the 2 I's weren't pronounced the same.
Radii.
That is a really dumb way to spell it.
Yeah.
You're right.
How are you?
There's no better way. That's what it's like saying like, hey, look, there's a group of mooses over there.
No, you can
there's
just do
a-
R
It
A
should be
D
meese.
E
Meese.
I.
Meese and geese. Sheep
R-A-D-E-I.
and sheep. It should be
So, as long as you now start to put into your brain the conversion factor of pi radians equals 180 degrees, we can work any degree measure into radians and any radian measure into degrees by just swapping out.
I feel like this is
And that's it. We got like 7 minutes to work on homework. So we will start to more and more do unit circle work, but not yet. Like, you don't have to have it memorized yet. More on how to calculate all this, more on your how we got the radian measures.
Well, how much is 1 radian though?
What do you mean, 1 pi radian?
No, 1 radian.
Like a bad number, because pi radians is 180 degrees. So pi, like that's